NASA and ESA have released new images of 3 Atlas. However, the images were not taken from Earth, but from Mars. At the beginning of October, the interstellar comet approached the red planet. And although none of the Mars missions are designed to photograph mysterious visitors, the probes achieved something amazing. They captured the distant faint comet on camera. However, these revolutionary observations also raise new questions. Why is 3 Atlas so much more massive than previous interstellar visitors? And why does it show hardly any tail? What is a mysterious streak of light that the Perseverance rover photographed in the Martian sky? And why did many NASA websites go offline temporarily at this particular moment? Be sure to stay tuned until the end and join us in getting to the bottom of these exciting questions. In early October, the interstellar comet 3I Atlas approached Mars to within about 30 million kilometers, offering a unique research opportunity for the probes and rovers stationed there. But this naturally raises a question of why the chunk of rock was examined from the red planet of all places. And the answer is easy to find. From our perspective, the object is currently located almost directly behind the Sun, making it impossible to observe with Earth-based telescopes. Mars, on the other hand, has no astronomical blinders on, and so it came to pass that 2 European probes turned their technical eyes on 3 Atlas. Specifically, these were the ExoMars Trace Gas Orbiter with its CASIS camera and Mars Express. Of course, neither probe was specifically designed to explore interstellar objects, but those responsible wanted to take advantage of this rare opportunity and make the comet as visible as possible. The Trace Gas Orbiter succeeded with flying colors, even if the images did not, of course, achieve the razor-sharp level of detail of the James Webb Telescope. And yet, a faint diffuse point of light was visible in the images. But what exactly are we seeing here? Well, in fact, this point is not the solar core of 3 Atlas, but its coma. So, what we are looking at here is a gas and dust-filled comet shell that forms when such an object approaches the Sun. The actual nucleus is probably only a few kilometers in size and therefore too small to be imaged in detail. The situation is quite different in the case of a coma. However, this extends over several thousand kilometers and glows softly in the images against the pitch-black background of space. At the same time, the glowing mantle also shows that 3 Atlas has become active because the frozen gases evaporate as a result of solar radiation and draw dust with them, which is what causes a luminous cloud to form in the first place. As we can see, however, we search in vain for a distinct tail in the images. This is simply because the chunk is still in an early phase of its activity and, as a result, the ejected particles have not yet accumulated in one direction. As the distance from the core increases, the brightness of the coma decreases rapidly, causing the outer areas to disappear in image noise. A visible tail will probably only form when 3 Atlas approaches its perihelion, or, in other words, the point closest to the Sun. However, the fact that the Trace Gas Orbiter managed to capture the interstellar visitor at all is absolutely remarkable. Nick Thomas, the lead scientist for the CASIS camera, states that the object was 10,000 to 100,000 times fainter than anything the camera normally captures. Against this backdrop, the images become even more astonishing. But what did Mars Express see? Well, somewhat different. The probe, which has been observing the red planet for over 20 years now, took its photos with an exposure time of only about half a second. By comparison, the CASIS camera has an exposure time of 5 seconds. The comet was not visible in the fleeting individual images from Mars Express, which is why those responsible are combining the photos to extract a faint point of light from the noise. However, at the time of writing this video for you, the work is still ongoing, as is further analysis. The 2 ESA probes attempted to measure the light spectrum of 3 Atlas in order to gather further clues about its composition. However, it's currently unclear whether the corresponding signal was strong enough. What is clear, however, is that this was the first time in history that an interstellar object was observed from Mars' orbit and that the Perseverance rover also set its sights on our extraordinary guest. A bright streak above Jessel Crater. Unlike the 2 ESA probes, however, Perseverance is not orbiting the red planet. It had been traveling across the surface of our dusty neighbor since February 2021. Despite this, The rover also managed to photograph 3 Atlas. On October 4th, one of its navigation cameras captured a faint bright streak cutting through the darkness of the Martian night sky. In and of itself, the navcam is not intended for astronomical observation, but mainly helps Perseverance find its way around. But on that night, the camera quickly retrained and showed the traces of the interstellar comet passing over Jezero crater at a distance of about 38 million kilometers. At first glance, the motif appears long and symmetrical, almost like a full-grown tail. However, this is not the case because the camera perceives distant objects differently. One pixel covers about 12,000 kilometers here, and the comet's movement during the exposure creates a blurred streak. According to current estimates, the true size of 3I Atlas is a maximum of 5.6 kilometers at its core, surrounded by the coma, which is about 3 to 5 orders of magnitude smaller than the luminous streak in the Perseverance image. To make the comet visible, the Perseverance team combined several short exposures to extract the object's light from the image noise. At the same time, other NASA orbiters also pointed their cameras at the same section of the sky. These included the Mars Reconnaissance Orbiter, which took images on October 3rd with a significantly higher resolution than the Perseverance camera. The corresponding images were intended to help determine the size and structure of 3I Atlas more accurately. But then, of all times, part of NASA's websites and data feeds went down. And the internet wouldn't be the internet if it hadn't immediately come up with a series of astonishing explanations. Isn't it possible that NASA found something so unexpected that it should never be seen by the public? Well, not necessarily. The restricted access to NASA's websites had less to do with aliens and more to do with the current political turmoil in the U.S. The U.S. government shutdown, which began on October 1st, led to the furlough of many NASA employees and thus to a delay in data processing and image release. An interstellar heavyweight, what insights the images provide? Given the exciting insights that our Mars outposts have already provided us with, we should not forget that the images also have great scientific value. They show how the comet glows, what its coma looks like, and how it moves across the sky. And in combination with additional analyses of its orbital motion and outgassing, experts were also able to estimate the size and mass of 3 Atlas more accurately. As mentioned above, the comet has a nucleus about 5 kilometers in diameter, surrounded by a much more impressive coma thousands of kilometers in size. However, what is particularly striking is the mass of our visitor. Although the object is racing through the solar system at over 60 kilometers per second and has a significantly active coma, its trajectory is only minimally deflected by outgassing. But first things first, comets normally move according to the laws of gravity. But when they are active, the sublimation of gas generates small recoil forces that slightly deflect them from their trajectory. And again, just to clarify, sublimation means that the frozen substances of the comet evaporate directly into space without first becoming liquid. This is how the luminous coma is created. Now, the so-called non-gravitational accelerations can be measured by precisely tracking the trajectory. But in the case of 3 Atlas, only a minimal deflection is apparent. Despite the visible coma and strong activity, its speed changes only extremely little due to outgassing, about 15 m per day. Compared to its cosmic travel speed of over 60 kilometers per second, this is negligible, which in turn suggests that its core is exceptionally heavy. The principle here is that the more mass the core has, the less effect the outgassing has. Based on the data collected, researchers estimate that the core of 3I Atlas weighs more than 33 billion tons. This makes our guess significantly more massive than its 2 interstellar predecessors, Oumuamua and 2I Borisov. It's important to note that the enormous speed of the chunk does not contradict this assessment. Speed alone does not say anything about mass. What is decisive is how strongly outgassing influences the trajectory. And in fact, the comet will even pick up speed in the future, accelerating to 68 kilometers per second as it approaches its perihelion. Despite this, the Mars probes were able to precisely measure the brightness, coma, and trajectory of the cosmic speedster. There is still much to be clarified, but every observation, regardless of the celestial body, helps us to find out more about our interstellar visitor, and the potential for knowledge that comes with it is even greater. Every cosmic guest also carries information about its home system, and thus valuable clues about how planets and stars are formed in completely different regions of the Milky Way. And in the area below our video, you can now even subscribe. Simply click on the thumb icon and then unsubscribe to never miss another new post from us. See you soon.